We are less than a month away from launching NASA's next Earth-observing satellite. I'm Raquel Villanueva, and today we're at Vandenberg Space Force Base, where the Surface Water and Ocean Topography spacecraft, also known as SWOT, is undergoing its final preparations before launch. This is the Mission Director Center, where just a few weeks from now, teams will be monitoring SWOT launch operations. But to get a closer look at the spacecraft and to hear more about its mission, let's get suited up and head into the clean room. And here it is. You are looking at SWOT inside the Astrotech clean room, and I am joined today by Phoebe Rhodes-Wickett. She is leading mechanical activities here inside the clean room. Thank you for joining us today.
Thank you for having me.
So Phoebe, can you tell us a little bit more about SWOT?
Yeah, so this is our baby SWOT. It stands for Surface Water Ocean Topography, and this mission is going to help us understand the water on our planet better. So as we know, water is a finite resource that we have, and it's really important to know where it was, where it is, and where it's going. And SWOT is going to help us with that. It uses advanced technology to take snapshots of the water on our planet so that we can better plan for things like droughts and floods and just better help prepare our communities for what's coming.
And how long have you been working on the mission?
I have been working on this mission for 8 years, which is exactly a quarter of my life.
Wow.
And so I started working at the mechanism level and then built up into where I was part of the deployable team for all the deployable structure on this spacecraft, which is basically everything that unfolds once we're in space on the payload side, which is what JPL delivered. And so that basically, once we're in space, we go through a 3-phase deployment. So we start all tucked up like you see here today, and then we go up through stage 1, out through stage 2, and then the 3rd stage deploys the antennas until we're out to about half a tennis court size. It's 10 meters.
Oh, that's a great description of it. And can you tell us what is going on in the clean room right now? How long has SWOT been here too?
Yeah, so we've been here for a few weeks. We came over from France after being there for a little over a year. And we've now been in the clean room. We're going through the final activities before launch. So we're making sure everything is cleaned and ready to go. We're removing all the items that we don't want to fly with the spacecraft. We're installing our last little touches. We have some ground supportment that's on here for the test that has to come off. And then we can close up all the blankets, which keep the spacecraft nice and warm in the cold space environment.
And can you tell us a little bit more about this gear we're wearing and why we have to wear it inside this room specifically?
Yeah, so it's important to keep our spacecraft clean. I was just talking about the hardware I care the most about, the deployable structure. And for that, it's important that there could be contaminants on surfaces. And then when we go through launch, you can just picture if you had dust, it will spread out to probably places you don't want it to go. And so we don't want that contamination to get inside the mechanisms and keep us from being able to successfully deploy once you're in space, or to get on any of those surfaces where, it's very important that we come together and our final deployment and everything is where we need it to be. Our alignment requirements are within the 1000th degree. And so it's really tight and we need to make sure it's successful, and keeping everything clean is part of how we do that.
That makes sense, and why we have to wear these hairnets with us now.
But they are cute.
It's a look. I like it. I'm digging it. And with less than a month left to launch, how does SWOT get over to the launch pad?
Yeah, so we have a massive shipping container that was used to bring it here from France. So we used a crane to lift it off of this dolly onto another one that then rolls into the shipping container. And then that shipping container is transported over to SpaceX, where it's removed and it's integrated with the rocket, and then it's moved to the launch pad, ready to launch.
And where will you be for launch?
I will be in Toulouse, France. I'm part of the deployment operations team. So we will be at CNES, which is the French space agency. And we will be going through the deployment process just shortly after launch, a couple days, and we'll get our baby all deployed and ready to complete a successful mission.
And what will it be like for you when you see those solar arrays open up for the first time?
I'm probably gonna cry. We'll see, but it's a long time in the making. There's already been so much sweat and tears and love poured into this spacecraft, and so it's gonna be a really special moment for sure.
I'm so happy for you. Thank you, Phoebe, for talking to us today. Now we are going to head over back to NASA's Jet Propulsion Laboratory, where our social media lead, Emily Richardson, is going to be with 2 other mission members answering your questions today. So if you have a question you'd like to ask, use the hashtag #TrackingWorldWater or leave the questions in the comments below.
Really soon, it's going to be encapsulated and loaded up onto the rocket for launch. For those of you who are just joining us, we're talking about SWOT, the Surface, Water, and Ocean Topography mission. It's led by NASA and the French space agency CNES, and it recently returned from its integration at the Thales Alenia Space Facility in France. It's scheduled for launch on December 12th. For those of you who have questions, you can drop them in the chat or use the hashtag #TrackingWorldWater. But first, let's meet our subject matter experts. I'm joined today by Ava Peral, SWOT Mission Performance Engineer, and oceanographer Matt Archer.
Hi.
Matt, yeah, thanks. Welcome, everybody. Thanks for joining us. Matt, you're part of the mission science team, so I can imagine that you're really, really excited to get the data back from this mission. Can you tell us a little bit more about what SWOT's going to help us learn about Earth's water?
Sure, yeah. So SWOT is a Pathfinder mission, which means it's putting new technology into space for the first time. So, us scientists are very excited. We're going to have a new data set that's going to give us, a brand new view of the global ocean water. And so, SWOT has 2 main branches. I'm an oceanographer, so, I know most about the ocean side of this mission. And we've been lucky for the last 30 years to have satellite measurements of the ocean, which, started decades ago. And it really, satellite imagery changed our whole view, because for the first time we were able to see how, the ocean's changing, not just in small locations or off ships, but over the entire planet. And SWOT is going to be extending this 30-year period out longer, and so the first thing it's going to be doing is helping us to maintain that unbroken record for understanding long-term changes. But the thing that's really exciting about SWOT is that with this new instrument that's going out into space, we're going to have a brand new view of the ocean. So it's going to kind of be like putting a pair of spectacles on the older satellites. Everything that we saw that was slightly blurry or fuzzy will now be, high definition clarity. And so that's going to help us to answer a lot of questions that we have about how the ocean works. And then SWOT's other branch is land-based freshwater supply and storage changes. And that might even be more exciting than the ocean component for the hydrologists, because this will be the first satellite that is launched that can actually study the global land-based water across the entire planet. And so that includes reservoirs and lakes, but also rivers. And so before SWOT launches, our ability to understand freshwater changes really requires a lot of work. It requires a lot of computational models, but also going out to rivers, going out to lakes, taking measurements. So SWOT is going to enable us to basically not have to do that as much and actually stand back and see everything at once. And so it's really going to revolutionize the study of freshwater hydrology. And of course that's going to have huge implications for how we make changes at the community level. So water resource engineers and managers can make changes on the ground based on what we understand about how much water is going in or coming out of specific locations.
Yeah, it's true. Water is so essential to everything on this planet. So as an oceanographer, what particularly are you looking forward to learning about the ocean from SWOT?
So I'm an oceanographer that specializes in small-scale oceanography. And so throughout my career, that's required that I kind of work on instruments that give us this high-definition view. And that usually means instruments that give us a very limited view in space, even though it's high resolution. So for example, when I was in Australia, I was working on a high-frequency radar that was deployed along the coastline. And that allowed us to look at the ocean over about 60 miles squared area. What SWOT's going to do is basically let us do that for the entire globe. So you can't really understate my excitement, because it's going to be able to see suddenly everything all at once. So yeah, that's my excitement.
Wow, that's awesome. And Ava, I understand you've been on the mission for 13 years. What's it been like seeing the spacecraft come together?
So yes, you're right. I've been on SWOT for 13 years. In fact, my whole life at JPL, I've been working on SWOT. When I came to JPL, my expertise was fiber optics, but I joined the radar team. The radar is the main instrument on SWOT. Over the years, I became the lead system engineer for this instrument, which is called Karen. And then after that, I became the SWOT mission performance. So for me, it's been a tremendous growth opportunity professionally. I've been very fortunate to work alongside very talented engineers, young engineers, very experienced engineers. We have all learned from each other. So now I'm super excited to be able to deliver this data to scientists like Matt. They're going to be answering very important questions about how Earth works and about how the water cycle works.
Yeah, amazing. And you mentioned Karen briefly, and Karen is an instrument that's really unique to SWOT and will set it apart from other Earth-observing satellites.
Mm-hmm.
Can you tell us a little bit more about Karen?
Yeah, so there are multiple instruments on SWOT. Several of them have been flown before, and the exception is really Karen, which is a very unique instrument which we have never ever done before. So Karen stands for a Ka-band radar interferometer. So it is a radar. Radars transmit a signal that bounces off the Earth, and it measures what we call the time of flight. It's the time it takes from the signal to go to the Earth and back to the satellite. But Karen is an interferometer as well. It has two antennas. You can see those in this model. This is one of the antennas, and this is the other antenna. And so when the signal bounces back, it's received by these two antennas. So what we measure, in addition of this time of flight, is the relative phase of the signal that comes to these two antennas. And these antennas, as you can see, are separated by this distance, which is about 10 meters, and that's about the height of a two-story building. And that allows us to get this very, very high precision. But in addition to that, the third aspect of that is the Ka-band. So this is a high-frequency radar. Ka-band is around 35 gigahertz. That means a wavelength of 8 millimeters, about the size of a fingernail, which means that the measurements that we make have that type of accuracy, the accuracy of about centimeter level. So what we're doing with Karen is we have the ability to measure the height of the water on the Earth to centimeter level accuracy.
Wow, that's so cool. It's time to take some social media questions because I have lots, but there are tons of great questions coming in from social media. So reminder, if you do have questions, go ahead and drop them in the chats or use the hashtag #TrackingWorldWater. All right, let's get started. Let's go with, since you were just talking about measuring different elements of the water, Bredney on Instagram wants to know, how does SWOT radar differentiate water bodies from the surrounding Earth?
Yeah, so the signal that bounces back from Earth has different strength if it's water or land. The signal from the water is about 10 times stronger than the signal from land. So we use image processing algorithms to differentiate between these two signal strengths. And with that, we're going to be able to determine not just the height of these water bodies, but also the extent, the area that they occupy.
Wonderful. And for Matt, what type of information on water is the satellite collecting for you and the science team?
Right, yeah, so over the ocean, it's collecting water elevation. And this has been a key measurement for us over those 30 years that I was talking about. What it allows us to look at is sea level changes around the world, and it also lets us to infer ocean currents, and therefore it allows us to understand how the ocean's moving, which plays a really important role, of course, in the whole climate system and and the whole, all of that.
Awesome. Another one for you, Matt. Danny on Instagram asks, what conditions could affect SWOT's measurements?
Right, yeah. Again, for the ocean at least, one of the key conditions is waves, ocean waves. When you have very stormy waves, that creates noise for the instrument. We're interested in the ocean sea surface height and not so much the surface waves. And so when we have like big stormy seas, that's going to degrade the quality of the measurement. So that's one example.
Ava, Mellophilic Athlete on Instagram, asks, which wavelength spectrum does it use to scan water, and how is it different from other satellites?
As I said, like Karen uses higher frequency than what has been done before. Most previous altimeter missions were using Ku band at around like 15 gigahertz. There was also a Ka band altimeter, but to my knowledge, this is the first Ka band radar interferometer that is going to be launched into space and be able to measure water from space. So that's about 8 millimeter wavelength.
Very, very precise. Like the spectacles that you're talking about, making it very clear. This is really an international mission. KVK Spaceflight on YouTube asks, which countries will SWOT's data serve?
You want to take that one?
Sure, I can take that. So SWOT has 4 major partners. We have NASA, obviously, here. We have CNES, which is the French space agency. And then we have 2 other partners, the UK Space Agency and the Canadian Space Agency. And they've all contributed to make this satellite a possibility. But the data we collect is a public service. So it will be available to anyone around the world who wants to access it. And that's kind of one of the exciting things, again, from the ocean perspective. You know, we're studying these very small-scale features now. And so we'll be able to look at these small-scale features, you know, anyone will be able to look at them. Scientists, you know, from Argentina to, you know, India and everywhere in between will be able to access that data and look at their own regional oceans. And of course for the land-based as well, rivers, lakes and reservoirs, you know, all countries will have access to it and be able to make, you know, engineering and water-based research decisions on this data.
Yeah. We have several questions about that because it does, like we said, it's really critical to everyone's lives on our planet. And the fact that information is going to be publicly available is really great. Do you know if it's going to be available in real time or what the kind of frequency of that's going to be?
Do you know?
So we were just actually talking about this before. Once we launch, we're going to have about 6 months in which we're going to be doing calibration and validation of the measurement. That means that we're going to be comparing the data that we measured with the instrument with ground truth and making sure that the measurement meets the requirements as we expect. After that, we're actually moving to a different orbit, and it's going to take months after that for that data to be available. And even after that, we might need to reprocess the data as we learn more about the measurement and about the type of signal that we're receiving. So it will not be real time for the current data. Some of the other instruments are part of SWOT that have a lot of legacy. They've been out in other missions before. The data of those is going to be available in real time.
Wow.
Yeah, and I can actually add to that the interferometer, the carrier in this instrument, is producing so much data. It's unprecedented for a satellite, and so there's people that are having to work on how to actually, you know, reduce that data to something manageable, and also how to make it available to people. And so we've moved from, you know, storing it in data servers and accessing it, you know, locally to putting it into a cloud-based service so that there's more accessibility and easier data storage. So you don't have to download and store any data to your computer. You can actually go and access it in the cloud. So that's something that's quite important with this mission, and that this mission has stimulated this kind of computational improvements.
Great. Nicholas on LinkedIn asks, does the spacecraft have the ability to change its orbit once it's in orbit?
So we are going, in fact, to do that, as I said. It's going to be first in what we call the Kalpa orbit, which has a repetition of 1 day. And then we're going to move it to a different orbit, which is a 21-day orbit, which is what we call the science phase. So after that, we're not planning to change the orbit anymore.
Okay. And yeah, there was an animation right at the front that I think showed how that orbit looks and how it scans the entire Earth, or most of the Earth. Combustion on YouTube asks, how does it know the difference between water and ice?
Do you want to take that? It's also about backscattering. So it is the difference between the strength of the signal that comes from the water and the land. That difference is higher than the difference between water and ice. So it's going to be more difficult to distinguish them. And we don't have any science requirements to measure ice, but it's certainly one of our goals. We're going to try to do our best to also get some science on ice.
All right. Roxana on Instagram. What do we hope to get from this mission in the long term? So we're talking about the next couple of weeks and months with getting this thing launched and up in space and its measurements collected, but what about the long term? What are we hoping to learn?
That's a great question. So the key thing with SWOT again is the resolution in which it will be measuring the water. We have these open questions in the oceanographic community about how energy transfers between scales. And what I mean by that is, the energy is forced at large scales. You have the sun heating the surface of the ocean, you have the winds blowing over the ocean. But the energy is dissipated or it gets destroyed at small scales, in turbulence, in all the mixture, when you think of, mixing a cup of coffee and all that stirring and turbulence. And so one of the kind of gaps in our understanding is what happens between the big scales and the tiny scales. There's this middle scale. And so SWOT is going to be providing a lot of hopeful, insight into these dynamics and to how this works. And that's going to give us that piece of the puzzle to understand better how the ocean works as a whole system, and also, how it interacts with the atmosphere. And so, for us, the basic understanding from a scientific, basic research perspective is going to change. It's going to improve on our understanding of how the Earth system works. From a forecasting or predictive viewpoint, this data will be fed into computer models, both for the atmospheric, for weather, for understanding how the weather's changing, but also for the ocean as well and how the ocean's changing. And so over the long run, we're just going to be improving, as this data is collected longer and longer, it's going to be improving our predictions and our forecasts. So, yeah.
There's so much that just is really important as we talk about climate change and the effect that it has on communities, on the coastlines, but also with droughts and floods. Which feeds into this question from Invincible on Instagram. Can it predict the future of land regions that might be covered by water due to climate change? Okay, that's a question for you.
Yeah. So one thing I haven't talked about so far is that interface of land and ocean. So not only are we going to have the hydrologists studying rivers, lakes, and reservoirs, and the oceanographers studying the ocean, we have coastal oceanographers and estuary scientists and delta scientists that are studying this interface. And because SWOT has a much smaller footprint, it has a much higher resolution, it's able to measure, really much closer to the coast than the previous satellites were. And so we will be able to understand, and we're going to gain a lot of information about sea level changes along the coast and how it's changing between countries and even, along countries' coastlines. And so it's going to help us to understand how the ocean is changing, how the sea levels are rising or dropping in some places. And so that would help us with understanding where land will be lost. And exactly.
Really relevant information. This one, I know we often get questions about this, so just putting it out there so we can kind of establish what SWOT does and what it doesn't. On YouTube, we have a question about does SWOT have the capability to measure subsurface water?
No, it does not. Because the SWOT radar signal doesn't penetrate the water, it just bounces off the surface. So it will not be able to measure the depth of the water. Or in hydrology, they're going to use models to try to estimate that. It's part of the information that they need to measure what they call discharge of the river, but it's not something that SWOT is going to give as a measurement. It's going to be deduced using some additional algorithms and predictions and ground truth.
And I can actually add to that. One of the exciting things in the ocean is that some things that happen at depth have a signature at the surface. And so SWOT will be able to actually give us kind of an insight into what's happening below the surface. Even though we can't see it, we can infer it from the surface signal. And that's one of the really exciting parts is, can we understand vertical movement in the ocean, how the ocean is taking heat from the atmosphere and putting it down deeper and vice versa. And so that's actually something we can infer even if we can't do it directly.
Great, thank you. And thanks to our social media audience for all of these great questions. There's just so many, and they're really putting you to the test here with all these questions. We have time for just a few more before we wrap up for today. Kingdom Kale on YouTube asks, the Prime mission is gathering data about water. Are there other smaller, similar functions that you hope to learn as well? If so, what would they record? Any bonus science that we're going to get from SWOT?
As I said, I know that, and we don't have people representing that here, but I know that there's going to be also ice science, coastal science, as Matt was saying, that we might be able to use SWOT for. And of course, once we launch, the data is going to be available. It's going to be globally available. So who knows? There might be things that we're going to be learning as we work on this data, on this measurement, and this might be helping other communities as well.
Great.
And I can add to that. There's something that's kind of cool is the surface of the ocean changes depending on the bathymetry of the seafloor. And so when you take a measure of the sea surface height, over long periods, you can actually extract the information of the seafloor changes. And so SWOT is going to be giving us way more coverage, way more measurements at high resolution over a long period. We'll actually be able to, not me, but other scientists will be able to extract how the shape of the seafloor in much higher resolution over the globe.
Yeah, thanks for adding that. Okay, let me see. We do have a few more questions here. One that I personally am curious about is, I know Phoebe talked a little bit about what the next couple of weeks are going to look like, and you mentioned a little bit about deployment. Ava, can you tell us a little bit more about what those steps leading up to and following launch are going to look like for the spacecraft?
Yeah. So we are now preparing for launch, which is going to happen in about a month. After that, the first thing that we're going to do is deploy the antennas. Here you can see them in the deployed state. All of this is folded into, as you saw in the video, inside here next to the spacecraft. So the first thing that we do is to open this up. This has to be done with extremely high accuracy. In order to get the accuracy that we need for the measurement, that has to be a fraction of the wavelength. Remember that the wavelength is about a fingernail length, and that has to be a small fraction of that. So now we're talking about really microns, like the width of a hair. So that's going to be the first step, which has a lot of technological challenges, but we need to be successful at that to be able to proceed. After that, the next thing that we do is turn on the instruments, and then, because we don't expect the deployment to be perfect, we actually have an alignment mechanism to co-align these two antennas to have them even more precisely aligned. And in order to do that, we're going to be using actual radar data to determine the alignment, and we have a mechanism that slightly rotates the antenna to improve on that. And then after that, we go into what we call the calibration and validation phase. First, for the instrument, we're going to do some calibration, but then for the whole measurement, we're going to be calibrating, measuring some constants, biases, offsets that we need to add to the data, and then validating that measurement, comparing that data, that measured data, with the ground truth, and making sure that the data that we obtain has the precision that we expect.
Incredible. It's going to be so amazing to watch that and to see all of those milestones get checked off. I bet you're pretty excited for it.
Yes.
So we're just coming up on the end here. One question I wanted to ask you both is, where are you going to be for launch?
Oh, Vandenberg. I will be there.
You'll both be up at Vandenberg.
Yes.
Yeah. All right. And last question coming in from LinkedIn. Dupana on LinkedIn. This is kind of zooming back a bit, big level, high level SWOT. What's unique about this mission compared to other Earth observing missions?
So I think we've been talking a lot about that. The most unique instrument is Karen, the K-band radar interferometer. It's going to give us accuracy in this measurement that is over an order of magnitude better than anything that has been done before, both for the oceans and for hydrology. And it's going to give us this global view that, as Matt was saying, is unprecedented. And it's going to be able to answer scientific questions and also open up new questions that we hadn't even never thought about before.
All right. Wonderful. Well, thank you so much. That's all the time that we have for questions today. Thanks to our social media audience for the wonderful questions. Thanks to Matt and Ava for answering them. And thanks to Raquel and Phoebe up at Vandenberg Space Force Base. SWOT is scheduled for launch on December 12th. If you want to learn more about the mission, you can go to swat.jpl.nasa.gov, or you can follow us on social media at NASA Earth or NASA JPL. You can also follow the hashtag TrackingWorldWater. Thanks so much for joining us today, and go SWOT!